Welcome back to HealthTech Explorers. Today we're diving into one of the important tools in medical AI, the confusion matrix. We'll break it down step by step so you can see exactly how doctors, data scientists, and researchers use it to make sure diagnostic models are accurate, safe, and ready for real-world healthcare. In medical AI and clinical research, accuracy is everything. But how do we know if a diagnostic tool or predictive model is truly reliable? Today, we'll explain the confusion matrix, a simple yet powerful tool that helps doctors, data scientists, and researchers understand how well a model is performing and whether it can be trusted in real-world healthcare settings. Imagine we have a test that predicts whether a patient has a disease. Every test result falls into one of four categories: true positives. The test correctly predicts that the patient has the disease. True negatives. The test correctly predicts that the patient is healthy. False positives. The test incorrectly predicts the disease when the patient is actually healthy. This is also called a false alarm. False negatives. The test misses the disease and predicts that the patient is healthy when they are not. This is the misdiagnosis. Why it matters in medicine. The confusion matrix is not just about counting mistakes. It provides a detailed picture of model performance, helping balance two critical factors: sensitivity, detecting as many true cases as possible so that no patient is left undiagnosed; specificity, avoiding false alarms that can lead to stress, unnecessary tests, and treatments; practical use in clinical research. When developing new diagnostic tests or AI tools for disease detection, researchers rely on the confusion matrix to evaluate whether a model is safe enough for clinical use, identify weaknesses that need fixing before real-world deployment, compare different algorithms to select the most accurate one, key metrics calculated from the confusion matrix. From this single table, we can calculate important indicators: accuracy, the overall correctness of the model; precision, how many predicted positive cases are actually correct; recall or sensitivity, how many real positive cases the model detects; F1 score, a single measure that balances both precision and recall. Understanding the confusion matrix is essential for anyone working with medical data or AI in healthcare. It ensures that diagnostic models are accurate, safe, and trustworthy, ultimately protecting patient health and guiding better medical decisions. Thanks for watching. If you liked the video, don't forget to give it a thumbs up and subscribe so you don't miss any future videos. See you next time.